Hello friends, today we are going to study about relative motion. In relative motion, first we will study what is relative motion. Then we will describe relative velocity and relative acceleration. After that, we will give some examples of relative motion. So let us move to first define what is motion. Here, motion can be defined as changing the position of an object under study with some reference point or observer. So if we have to define the motion of an object, we have to define first the reference point, and then we will define whether the position of the particle under study is changing. Then we can surely say that the particle is in motion. If the position of the particle under study is not changing with reference point, then we cannot say that we can surely say that particle is at rest. So whenever we have to define the motion of an object, thus we have to choose a reference point, and with that reference point we have to define the position of an object. As the position of the particle or object is changing, then we can say that the particle is in motion. So motion is the combined property of object under study and observer. There is no meaning of rest or motion without observer. Nothing is at absolute rest or absolute motion. So whenever we are talking about motion, we are actually talking about relative motion, because without describing the reference point, we cannot describe the position of an object, and so we cannot describe the motion. So any kind of motion that is described in nature or that is studied in nature, that is actually the relative motion. First we have to choose some reference point, and with that reference point we will study the object whose motion is to be defined or studied. Let's take an example. Suppose we are standing over earth. Suppose this is earth and moon. This is moon. Suppose we are standing here and we observe that earth, with respect to earth, moon goes in a circular path around earth. So this is moon. With respect to the earth, moon is moving in a circular path. Now if there is an observer on earth, he will observe that the earth is moving around moon in a circular path. So actually the motion that is observed from different frame will be different. From earth, we are standing over earth, we observe that earth is at rest, and moon is moving with respect to, if we are standing over the moon and we observe that earth is moving and moon is at rest. So whatever frame chosen for as reference point, that reference point becomes at rest, and the object under study, if changes its position with respect to that frame or reference point, then we can surely say that the object is in motion. Let's now move to describe it in more detail. Let's take a reference line, say y-axis. This is y-axis, and right of this as positive x-axis, and left of this reference line as negative x-axis. Suppose there is a two-lane road. This is the first lane, and this one is second lane. There are two bodies A and B. This is body A and this is body B. Both A and B are moving along this lane and one along this lane. After some time, suppose the body A which is over here and the body B which is over here, and these have position coordinates, say xa and xb. This reference line, that is y-axis, position coordinate or position of A after some time is XA and position of B after some time is XB. Here X and XB are the position of A and B with respect to this reference line, that is y-axis. Now suppose we are standing over here on B. With respect to this B, the position of A can be defined by an arrow. We draw an arrow pointing from B to A. This arrow represents the position of A with respect to B. The magnitude of this arrow can be written as XA minus XB. Since this arrow is pointing in positive X direction, so this XA minus XB comes out to be positive, and we can write it as XAB as XA minus XB. Here A is the object under study and B is the observer or reference frame. So position of A with respect to B comes out to be XA minus XB. Now we have to define, if we have to define the position of B with respect to A, then we can draw an arrow from A to B, this is, and this arrow is pointing in negative X direction. This arrow has same magnitude as XA minus XB, that is XA minus XB, but with a negative sign over here. Since this arrow is pointing in negative X direction along negative X axis, so we have to put a negative sign over XA minus XB, and we can write as XB with respect to A, position of B with respect to A as minus tan XA minus XB, that is equal to XB minus XA. So we have defined that position of A with respect to B is XA minus XB and position of B with respect to A is XCB minus XA. Let's now move to define all the positions and related velocities in vector form. Suppose there is a frame that contains x-axis and y-axis. Suppose this is y-axis and this is x-axis, this is x-axis and this is y-axis. Suppose this x and y-axis attached to a frame, say S, and this S is actually ground frame or attached to ground. Suppose this is origin. Now there are two bodies A and B having position coordinate RA and RB. This is body say A and this is body B. Position coordinate of A with respect to this frame, that is S, is RA, and position coordinate of B is RB. When we have to find the position of B with respect to A, we can draw an arrow pointing from A to B. This arrow will give the position of B with respect to A. We can write it as RBA. This is the position of B with respect to A, and here RA and RB is the position of A and B with respect to frame S, and RBA is the position of B with respect to A. We can write as position of B with respect to A, that is RBA equal to RB minus RA. Here RB and RA are the position of B and A with respect to ground or with respect to some frame that is attached to ground, and RBA is the position of B with respect to A. Here A is the observer and B is object under study. So RBA equal to RB minus RA. Now let us move to describe relative velocity and relative acceleration. We have just described position of B with respect to A equal to RB minus RA. Now we are going to describe relative velocity. We know that velocity is defined as rate of change of position with respect to time, that is v velocity equal to dr by dt, where it is the change in position and it is a time interval. So rate of change of position, here r representing the position. Rate of change of position with respect to time is known as velocity. So if we take differentiation of this equation, let us say this equation 1, and if we are going to differentiate this equation with respect to time, we will get d of dt rba equal to d of rb divided by dt minus d of ra divided by dt. Here d of rb a divided by dt is represent velocity of b with respect to a. We can write it as velocity of b with respect to a equal to velocity of b minus velocity of a. Here b, velocity of b, this term bv represents velocity of b with respect to ground, and this is also represents velocity of a with respect to ground, but this term represents velocity of b with respect to a. That is right, this is second equation. Now we can write, we are going to define the relative acceleration. We have just defined velocity of b with respect to a equal to velocity of b minus velocity of a, and we know that acceleration defined as a equal to dv by dt, that is rate of change of velocity with respect to time. We call it as acceleration. So if we differentiate this equation with respect to time, this equation with respect to time, we will get acceleration, relative acceleration. So differentiation of d of ba with respect to dt equal to d of bv divided by dt minus d of ba divided by dt. This is a acceleration of b with respect to a equal to acceleration of b minus acceleration of a. So is the acceleration of b with respect to a, and is equal to acceleration of b minus acceleration of a. If we know the acceleration of b and acceleration of a with respect to ground, these are the acceleration of b and a with respect to ground, then we can find out acceleration of b with respect to a. Let us write it as third equation. So we have just described position of b with respect to a equal to position of b with respect to ground minus position of a with respect to ground, and relative velocity as velocity of b with respect to a equal to velocity of b with respect to ground minus velocity of a with respect to ground, and acceleration of b with respect to a equal to acceleration of b minus acceleration of a. Here acceleration of b with respect to ground, here acceleration of a with respect to ground. Let us give an example. Suppose there is a tree besides a road, and this is the road, and on this road there is a car moving towards rightward. Therefore, this car is moving velocity u, and since tree is attached to ground, so velocity of tree with respect to ground will be 0. This is the u of tree with respect to ground is 0, and there is a man in this car. Since car is moving with this velocity u, this man is standing in the car or sitting in the car. This man is also observed at the this man is also moving with velocity u as seen from the or this observer, let us say this observer A, this observer is B. With respect to A, B is moving with velocity u, So we can write it velocity u of b with respect to a equal to uv minus ua. Since uv we have given as u and ua, since this man or a is at ground and with respect to ground this is not moving, so we can write it as 0. So velocity of b with respect to a equal to u. Since tree is also at rest with respect to ground, so we can also write it as velocity of b with respect to tree equal to u. Now if we observe tree from the reference frame of car, this observer B will observe that the tree is moving in backward direction. This can be proved as velocity of tree with respect to B will be velocity of tree minus velocity of B. Since velocity of tree is 0 with respect to ground and this is u, so it comes out minus times u. Here negative sign showing that if the car is moving in rightward direction with respect to tree and then with respect to this car or with respect to the man under in the car, the tree will be moving in backward direction or in left direction with the same speed u, but we have this negative sign showing that in opposite direction. So with respect to tree the car is moving towards right and with respect to this car the tree is moving towards left. We have observed this phenomena at various times in our life. Whenever we are going in a train or in a car and we observe from the window outside, we observe that all the objects which are attached to the ground like tree, fields, rivers, all these things move in backward direction with respect to us. So from ground frame this car is moving, from car frame this tree is moving. So whatever we choose as frame, this frame becomes at rest. So reference frame is always taken as rest. Reference frame is always taken as rest. Since we are standing over the frame or we are ourselves the reference frame, so our position will not change with respect to ourselves. So reference frame already taken as rest. Now we are going to summarize the whole lecture. So we have defined first position of A with respect to B equal to position of B with respect to ground minus position of A with respect to ground. And second we have described velocity of B with respect to A equal to velocity of B with respect to ground minus velocity of A with respect to ground. And third we have defined acceleration of B with respect to A equal to acceleration of B minus acceleration of A. This is today's lecture. Thank you. Have a nice day.